Okay, question 16 begins the reaction questions where we're given a particular starting material and a set of reagents. So on part A, we're given this alkyne when reacted with one equivalent of chlorine. So remember the structure of Cl2. And this means because there's one equivalent, 1 mole of this alkyne reacts with 1 mole of the Cl2. So the net result can only be the addition of 2 chlorines across this triple bond. What you have to remember is that in these additions we get that chloronium intermediate, which makes the chlorines add trans across that triple bond. So the triple bond becomes a double bond. Our chlorines end up trans, and we can't forget about these 2 ethyl groups that are attached because nothing happens to them. And that's our final product. In the second question, it's not much different except 2 equivalents of bromine are added. So we get addition of the first equivalent to go from the alkyne to the alkene like we did above. And then we get addition of the second equivalent to go to the alkane. So the net result is we add 4 bromines to this starting material. So if we have the phenyl group, here's where the triple bond was, and we get 4 bromines added, 2 on this side, and 2 on that side. Okay, part C is this BH3THF followed by sodium hydroxide, hydrogen peroxide. And when you see this, you should automatically think of the hydroboration, because that's what these conditions are for. So it's a hydroboration oxidation. Okay, one of the things you have to keep in mind is that hydroboration oxidation adds an H and an OH across that double bond. Also, you need to recognize that the hydroboration is an anti-Markovnikov addition. So that means the H adds to the side with less hydrogen. So on this side of the double bond, we have 2 hydrogen. On this side of the double bond, we have 0 hydrogen. Because it's anti-Markovnikov, the H adds here, the OH adds here. This goes from an alkene to an alkane in the final product. So we draw our cyclic ring. This now becomes an alkane. A hydrogen is added here. An OH is added there. And that's the answer.